Welcome everybody. You are at the Friday Tech Talk from Yugabyte, from engineers to engineers. So we are talking about features in Yugabyte. And today we have Kavya, solution architect. We'll be talking about PG Hint Plan. That is a Postgres extension and that we enable by default on Yugabyte. Hello, Kavya. You can introduce yourself.
Thanks, Frank. Hi, I'm Kavya Shivashankar. I'm a senior solutions architect at YugabyteDB, working with several customers and making them successful with YugabyteDB. I've been at Yugabyte for a little over 2 years, and and today's session is PG Hint Plan in YugabyteDB. I have a set of slides I'll be walking through.
Perfect.
Okay, so let's get started. So here's what the agenda looks like for the next 30 minutes. For the folks that are new on YFTT, I'll be setting the context on what YugabyteDB is. Then we'll jump straight into the topic, go to hints, why it is there in SQL. We'll look a little bit about the semantics of using hints. From then on, we'll look at how to configure and validate that PG Hint Plan is enabled in YugabyteDB. We'll step into PG Hint Plan phrases, all the different types of it. And then for each type, we'll talk about all of the hints that are available. We'll take a little slide change in terms of going into the hints table, which is also a way of enabling PG hints in YugabyteDB. And then subsequently, we'll go into the demo sections. Okay, so setting the context on what Yugabyte database is, right? Yugabyte database is a PostgreSQL compatible distributed database meant for your cloud native applications. It is a high-performance distributed database for any of your applications that need sort of like a distributed scale or even the ACID type of transactional capabilities. It automatically shards the data that you store in the database, so scaling out is very easy, and it comes with default resiliency. It can be deployed on any of the cloud providers as well as in hybrid mode, and it's also supported in the on-prem context. Now, let's jump into the topic for today, which is hints. Hints, what are hints, right? Hints are a way to tell your query layer to choose a certain plan to execute the query. Since SQL is a declarative language, the query planner generates procedural code to access data, and the way it generates this procedural code could be using table data statistics and some static rules to derive the execution plan. PG Hint Plan extension in Postgres, and which is also available in YugabyteDB, gives you a way to tweak these query plans. While the planner optimizer does its best to choose the right execution plan, sometimes it's not always perfect. The reason being, your application code, or rather the application data, can have certain data properties which you as an application developer would know about it, and there's a certain set of correlation between columns. So you want a certain different plan to be chosen than what the optimizer chooses. So PG Hint Plan makes that possible by using what is known as hint phrases. Now, hint phrases are descriptions in the form of SQL comments. They typically begin with like a character sequence of a /* plus and ends with a /*. So essentially, you're kind of using hints to understand the choices the optimizer is making. Or you may also work around, certain, I shouldn't say bad, but certain different choices that the optimizer picked up. Or you want to kind of compare with the kind of data set you have. You want to compare what each of those different plans, how they help you or how they don't help that context, right? Moving on, let's see what the semantics for using the hints are. So hints are typically, the hint phrases are typically placed at the beginning of SQL, of the SQL statement. They are usually, they have to be embedded within that /* plus and the /* sort of, they are delineated by that. They have those delimiters in which they're enclosed. Hints can be used on prepared statements, or rather should be used on prepared statements and not execute, because planner is something that that is running at sort of like before the execution phase, and then subsequently gets used as part of the execution. Right? So it has to be done on the prepare statement and not the execute statement. For multi-statement commands, a hint that is placed at the beginning will apply to all the SQL statements in that block. Typically, when you write SQL queries, there's a general tendency to use aliases for tables. So in that specific context, the hint should use the alias name and not the table name. It's only when you use the alias name that the hints will get picked up. They are case sensitive, so that has to be kept in mind. Then hints have hints when you, in this example, like for example, hash join, and you specify hash join is a hint and you specify 3 tables in it. The order of that is not in the order that you write unless you enclose it within parentheses and use some sort of nesting, right? So, like for example, the lower portion of the presentation talks about hash join. Hash join ABC is the same as hash join CAB. But if you want A and B to be considered, tables A and B to be considered first, you enclose that within parentheses, and that example is shown in the leading example here. So how do you check if PG hint plan is configured in YugabyteDB? First of all, in YugabyteDB, PG hint plan is automatically configured because it's part of the shared preload libraries that's loaded up into Yugabyte database when you install it and you start it. So there are 3 parameters. One is the PG hint plan enable hint, which can be used to which tells you whether the hint plan is turned off or on. The default is on. There are 2 other configuration parameters called debug print and message level, which gives you the ability to control the amount of output that PG hint plan gives you. And that by default have a value of an info and can be changed depending on the needs of your application and what you're doing for that application. Now let's look at how what are those commands that you can use to to validate that PG hint plan is configured in YugabyteDB. So that you can select it from PG settings to specifically look for that PG hint plan.enable hint, and it should tell you that it is on. That setting column will tell you that it is on. There's also another way where you can say show PG hint plan.enable hint, which will again give you the option that it is turned on. This is why SQL session is the Postgres. The client, the CLI to the Postgres API, and can be invoked once you have the cluster up and running. So now that we've seen that PG hint plan is enabled in YugabyteDB, let's look at what those different types of PG hint plan phrases are. The phrases can be to define scanning methods where you instruct the query to say that, hey, pick up sequential scan instead of an index scan, or maybe pick up one particular index over another. So it is instructing the query to pick up an appropriate scanning method. Similarly, you can instruct the SQL query to say that pick up a certain join method, and you can specify the join order on if your query has multiple tables. You can specify the join order in a PG hint plan phrase. You can also use to configure planner parameters, and we'll go through each of this in the demo that is planned for a little bit in the presentation. So jumping into each of these different phrases, right? Let's look at what the hints are for different scanning methods. So there is Yugabyte supports sequential scan. It allows you to say don't pick up sequential, as in do not enable sequential scan on the table. It gives you the ability to pick up a specific index on a table with index scan table. And there's an option also to say, do only an index scan. That is, pick up everything from the index only, assuming that your query has all of those columns that are included in the index. To say that, hey, do only index only scan, in the sense, don't go to the table to pick up any additional columns. And that is dependent on how the index is defined, right? It also has a scanning method called index scan regexp, which enables index scan on the table whose indices match with the regular expression defined by the regex. And there's that other, the other equivalent of index only scan for that, which does a similar thing, but it scans only the index. So these are all the hint phrases which can be included in your SQL statement, and they instruct the joining method, the scanning method for that particular SQL statement. Now let's look at the hints for join methods. Yugabyte supports several different types of them, and these are hash join, where you say hash join with a set of tables gives you join T1, T2, T3 using the hash join. If you don't want hash join to be used, there's a hint that says no hash join. And again, you have to give a set of tables which you don't want to be joined via the hash join. Nest loop is an option which allows you to go into nested loop type of join. And similarly, if there is a need for you not to do nested loop, which may be for whatever size of the data set, considering the size of the data set, there's an option to give you no nested loop. Yugabyte also has an optimization called batch nested loop optimization, which is essentially an enhanced performance of the nested loop joins. Here, in versions 2.21 onwards, that nested loop optimization is available as an additional hint in the Yugabyte database. And this is a huge advantage, huge optimization advantage, because it batches multiple keys of the outer table in a nested loop join into one RPC, and so kind of restricts the amount of requests that get sent across to different nodes in a nested loop join. So there is that, this kind of flexibility is a huge advantage, especially when you're doing performance tuning and trying different combinations of what works best for the application.
Yeah, I've seen that batch nested loop solves many problems where other methods are not really good when we deploy with some latency. We have a question. A question about index-only scan. When you use index scan, does it prevent the planner from choosing index-only scan?
When you use index scan, the SQL statement gets instructed to use index scan, right? So if you explicitly specify a hint as index scan, yes, it chooses index scan. But in order for you to instruct the planner to pick up index-only scan, index-only option has to be used.
Yeah.
But even if you don't, if you don't use any of these parameters, a lot of times you'll see that the planner is very intelligent enough to actually pick up an index-only scan if it finds that all of your columns are available in the index.
But it's a good question, because that means that with ints you can do things worse.
Right.
If you don't put the right int. Yeah.
Correct. That's true.
Thanks.
Okay. Let's go into the hints that are meant for the join order, where you can. So typically, when you write an SQL statement, it's usually select whatever from table 1, table 2, table 3. You usually write it in the order that is very intuitive for a developer, right? A lot of times you may want to change the order because you realize that the data set in each of these tables are very different. So in that case, rather than rewriting the query, there is an option to instruct the SQL to use a different join order. And here, this example here, it says leading T1, T2, T3. Essentially, you're saying that take tables T1 and T2 first, and then go into T3. Whereas if you, on the right-hand side, that hint which says T2, T3, T1, it's instructing the SQL to go in the order of T2, T3, and then T1 to do the actual joins. So this, again, if used right, is very useful because it gives you the, you don't have to think through when you write the query itself, but you can use the hint to instruct the query to do the right thing. Okay, this is the fourth option about hints for configuring planner parameters. It gives you, again, a method of influencing the query plans chosen by the optimizer. And YugabyteDB supports a lot of these configuration parameters. So essentially saying, let's take an example, enable hash join, right? So before the query, if you say set enable hash join, that query, irrespective of what it would have otherwise chosen, will be instructed and forced to use a hash join. it's sort of like specifying the this kind of scanning methods. It's sort of a combination of scanning methods, the join types, but it gives you that ability to instruct the query to say that use this parameter rather than specifying the hint phrase as a scanning method itself.
And we have a question from Jim. Is there, for the batch nested loop int, is there a way to apply it to all joins instead of specifying the tables? And I think this fits in the configuring planner parameter, because with 221, we have added a specific int, but we have also added a YB enabled batch DML to set it. So before 221, the batching was the same as the nested loop with just a batch size. And after 221, we have a specific int, but also a specific parameter.
Cool, thanks, Frank. Let's talk about hint tables, right? So all this while we talked about how you specify hints with the SQL. And a lot of times, especially if you have large application code having different workflows, but using similar type of queries, it kind of becomes overwhelming and cumbersome to include it on every single query used in the application. So there is hint plan hints table that gives you that ability to store the query along with the hint in the hints plan table. And so every time the query gets executed, the appropriate hint gets picked up. The disadvantage with this, though, is that if the query, it's not as easy to change the query, because if you change it in the application code, you have to make sure that the hint plan hints table also is changed in order to pick up that index that you instructed it to pick up. But definitely grouping queries of similar type is like a huge advantage with this, and can be used, depending on what the use case needs. Okay, so let's look at a demo of all of what we've talked about. And let me go to my shell.
Perfect. And in the meantime, if people have questions on LinkedIn or YouTube, do not hesitate.
Okay. So Frank, you're able to see my Cloud Shell.
Yes, perfect.
Right? And okay. So for this example, for this demo, what I've done is I have 3 tables. Let's look at it here. Table 1, 2, 3. I've preloaded it with a little bit of data. And here's what the description looks like, right? T1 has the primary key is ID, and I have an index T1 val. Similarly, T2 is also like that. It has the primary key is ID, and this is secondary index on val. My T3 has 4 indexes in addition to the primary key. So let's talk about let's go into the demo of how to specify the hint for the scanning methods. So I'm going to run one command, an explain plan, which is this. And here you see that it's picking up the nested loop with seek scan on T1, and T2 is index scan. Let me alter it by saying I want seek scan on both T1 and T2, because I know that these tables are small, and so I can maybe afford seek scan instead of nested loop scan, right? And here you see that the seek scan on table, it did a seek scan on table 1. It also did a seek scan on table 2. However, it changed the join type, but which is fine. Because we specified only the scanning method to change. So let's look at so in the first query when I ran, it did pick up an index on T2, and now I'm saying do not pick up any index on T2, right? Let's see what it did. So it changed from being an index scan on T to seek scan, but it found that doing an index scan on T1 is a lot better. So it just reversed that. If you look back here, from seek scan on T1, it went to index scan on T2, but T2 itself, which was index scan, became seek scan, because that's what I said. Do not do any index scan on T2.
So it follows your int, but still decide on the cost on the remaining choices. Yeah.
Right. So let's look at a couple of examples on how do you specify a specific index, right? I'm going to run this thing, and it said index, and it used the ID as an index. And now I'm going to say, hey, you remember, if you remember, I had like 3 indexes on ID along with the primary key and also a different one on val. So I'm going to say use my T3 index, index 2 on T3. And let's see what it does. Okay, so when I instructed it moved away from using the primary key index and used the index that I gave here as part of my hint parameter. Similarly, I can say I have another option to say don't use index scan, but do not use it. So then it this is as good as saying sequential scan on T3, but it's a it's convoluted way of saying it. But essentially, it moved away from using an index scan and asked it to did a sequential scan on T3. So
and that's interesting because we see how it works. It puts a very, very high cost to try to not use it. So it still use it because it doesn't have the choice, but with a very high cost here.
So now that we've seen the scanning method and the specifying the index types, let's look at join methods. So I'm again going to run a query that without any hint, and here again nested loop and then seek scan and index scan. Now I'll instruct the query to do a hash join instead of nested loop join. Let's see what happens. And here you see that even in terms of performance, right, though this was the default being picked up, because of the size of the data and the type of the data I have in T1 and T2, a hash join turned out to be a lot quicker than the nested loop join. And this exactly, this scenario demonstrates as to why PG hint plan is a huge advantage when trying to figure out what plan you should instruct or should be used for the type of the query that is executed in the use case. Okay. My cluster is on 2.20 version, so I wouldn't be able to show the batch nested loop, but I would recommend trying 2.21 version and see how try it out yourself as to how batch nested loop works. Let's go into the join order. I will again start with a query without a hint. And so the join order is T1, T2, and then T3. So now I'm going to instruct it to say, hey, do T2, T3, and then T1 without changing the query. So the query still remains the same. It still select star from T1, T2, T3, joined on the IDs. But my join order here says start with T1 and T3, and then use that to join with T1. And see here, you see that here. See that difference right here in the explain plan output, right? It's starting with T2 and T3 and then going and joining with T1, which is different from what we saw when it defaulted to the order that was specified in the query. So the fourth thing that we talked about was the configuring of the planner method parameters. And let's take a look at that as well. Again, as usual, I'm going to execute a standard query to get the explain plan output. And then now we see that it used index scan. So I am going to turn off index scan by setting that planner configuration to, which is enable index scan to off. And this is how I do it. I say set. This is sort of a little different than the hints that we've seen so far, right? Here you're actually doing a set of this configuration to off. And there you go. The index scan is no longer used. And instead, it picked up the hash join, but as a join method, but picked up the sequential scan on the tables to actually do the join. So this is an example of how you can turn off or on specific planner configuration methods to do what is most optimal for you at that point in time. So now that we've seen all the different hints, let's switch gears a little bit and go to hints table. Now, if you remember right at the beginning of the conversation discussion, I talked about how hints is automatically, PG hint plan is automatically enabled because in Yugabyte, because it's preloaded. But for this particular hints table, you have to install the extension explicitly, because this part of it is not preloaded. Like that is the enable hints table is not preloaded as part of a default Yugabyte installation. So we'll create the extension and we'll set. Let's see whether what it shows. Show. I'll say show like this, and it shows it's off. So let's turn that on now. And I'll do a show again to say that, okay, the hint plan is available. Now I'm going to, I have a query which I'm going to insert into the hints plan table, or rather hints table. And this is my query. I say explain, analyze. I'm selecting from T1 where T1 val has a certain value and asking it to use index scan on T1. So I've created it. I'm also going to insert another query, SQL statement, where I'll give the same query, but similar query on T2, but I'll now instruct it to use sequential scan on T2 and not the index. Both of these tables are very similar. They have the same indexes. That is on T1 val, there is an index. On T2.val also there's an index. But for the second query, I'm asking it to do sequential scan. It's inserted, and just let's take a look at how the hint plan, hints table is. And here you see the query as well as the hints that are on it.
We have a question that I think is related from Jose Carlos Paron. It could be similar to stored outlines and SQL patches in Oracle. Yes, a bit, not as powerful as what is in Oracle, but that's the same idea. And this is exactly what you are showing. It stores the query and it stores the hints to apply when it finds the query.
Okay, so let's do this now. I'm going to do an explain analyze on the query that is here. And it did pick up an index scan on this. Now let's actually validate if the other one is, because I have an index on T2, but I'm instructing it to do a sequential scan. So I have it's become sequential scan rather than the index that's available on T2.val. Well, yeah. So yeah, these are, this is all I had for the demo, Frank. I think it covered.
Perfect. So something that is interesting also there to show the limit of this PG plan table. You want to use an explain, and then you had to put the explain because it takes the whole statement.
Right. All right, here. Yeah.
Okay, we are nearly on time, so let's see if we have questions. In the meantime, we have Eshwar wishing you a good evening. Eshwar is one of our very frequent followers on YFTT. And if there are other questions, let's see. Sorry, there is a question. Is there some mechanism to check for spelling errors in PG int plan? So you mentioned the debug once. If you set the debugs, then you may have some clue. Maybe it's not as easy as it could be, but at least with the debug one, you can see if there is an error in the int or not.
That's a good one. That's a good one, Frank. How do you check for human errors like spelling mistakes, right?
Yeah, because you see the execution plan, but you don't know if the execution plan was chosen anyway by the query planner, or if it was specific to your hints. So yeah, with the debug hints, you can have more information, but yeah, it's not easy. Personally, I see hints for two reasons. One is investigating on different plans to understand the performance, and that's really cool. And the other one is work around production issue, and then it should be limited, keeping in mind that it is a workaround. You don't want to, for example, in this int table, I suppose you don't want to have hundreds of different statements. That would be difficult to maintain. Okay, we are just on time. Let's check if there is any more questions, and if not, that's perfect. Thank you very much, and the demo was really nice to show all that.
Thanks, Frank.
Let's see if we have questions.
We have the Slack channel, and also GitHub is fully open source. So, I mean, I would advise or recommend the users to go join our Slack channel to know more about Yugabyte, as well as can go into the GitHub to look at what we are working on.
Good point. And this YFTT is recorded and available on YouTube. So if people watch it later, then do not hesitate to ask your question on Slack here. Okay, thank you very much, Kavya, and thank you all people. Have a nice day or evening. Goodbye.
Thanks, Frank. See you all.